All right, well, today I'm going to be talking about men from Mars, women from Venus. Both can code .NET in Jupyter. Good afternoon, good morning, good evening, good early morning, or wherever you are in our virtual world. I appreciate you all coming to this event and also uh, for my presentation here. My name is Ron Dagdag. I am a software engineer at Spacee. But before I get started, I want to tell you a backstory why I chose this title. Get to make sure my clicker works here. So my wife and I, we're both been a .NET developer since back in the days. We're old. 2003, my wife actually started more doing .NET development back in 2003, and I been a .NET developer back in 2005. I started as a .NET, with .NET framework 2.0, and she started .NET Framework 1.0. I remember, we were talking about the differences between 1.1 and 2.0 back then, uh, and then my current job, I do a lot of .NET, in terms of Internet of Things and AR applications. My wife, uh, she works in a large enterprise application, maintaining .NET framework. I do a lot of .NET Core lately. Of course, .NET 5 is gonna uh, put it all together. So I work for a startup. She works on a software that makes lots of money. So thinking about this is like, we feel like we're both in .NET, both .NET developers. We feel like we live in that same .NET solar system, but it feels like we both live in two different worlds, right? She's maintaining enterprise applications, a lot of money, and I'm doing a lot of the, what's new in .NET. And then, these days, with all the data science and data engineering, uh, we kept on hearing about this another world out there in the world of data science, where you know you'll hear Jupyter, that they use that, and I heard that a lot of Pythonistas live in that area. So, and it's real because they have a mug that they can show off. But yeah, it feels like it's a totally different world out there if you're coming from as a .NET developer and getting into you know the world of notebooks and all this. So today my agenda is to talk about what is Jupyter, Jupyter Notebooks, and Jupyter Lab, and then how does it connect to .NET using the .NET Interactive, and how to run .NET in Jupyter Notebooks. I will demo today how you would run it inside uh, a Raspberry Pi and how does it connect to a Raspberry Pi, and then we'll end the day with that. So hopefully our goal is to land somewhere in Jupyter, right? That's the goal for today. Doing Jupyter stuff. All right. So what is Project Jupyter? Project Jupyter is the um, is is an open source web applications that got started back in 2015. It is specifically made to share live code, equations, visualizations, narrative text related to being able to more of the exploration side or interactive data science side or scientific computing, not necessarily in terms of uh, the way we would program .NET, where you have these more of the application development, and this one is more in the interaction, and I'll kind of demo that later on. Jupyter is coined with with the first few kernels that it can, they call it kernels, but backend systems that it can support, or languages that it can support, Julia, Python, and R. It used to be called IPython notebooks, but these days Julia, Python, and R is not, it's not just limited to that. There's other languages, you can incorporate to Jupyter Notebooks. It's licensed under modified BSD license. So if you're interested in that. .NET Interactive allows us to have a kernel, or have that capability where we can write C# applications, F# application inside Jupyter Notebook. So of course it's not just limited to that. There's also Interact and Visual Studio Code. You can incorporate. There's Jupyter integration to Visual Studio Code. So at the end of the day, what we want is to be able to just share code, explore data, learn across applications. It's .NET Interactive is just unleashing .NET into other areas of development. So like was said, .NET in Jupyter Notebooks is more related to the different kernels. So the .NET Interactive allows us to be able to have C#, F# as part of the backend or languages that it can support, and also PowerShell, of all things, right? You can actually run PowerShell inside Jupyter Notebooks now. And I'll be talking about this magic commands, which is a list of commands that you can use inside Jupyter Notebook. And how, there's also the concept of Pocket View. Pocket View allows you to be able to display HTML code. And these are all running in the browser in order to connect to it. There's also an XPlot library for visualization, where you can have HTML code, charts, and all that. And I will demo that today and how we can use that inside .NET Interactive. Any questions so far about .NET or .NET Interactive, and how we can use it? Because I'm gonna this session would be more demo based. I'll be showing a little bit more code. So I just want to make sure that we kind of both understand. .NET Interactive is more, being able to run .NET inside Jupyter Notebook or interactive experiences. The best way, or the easiest way you can have these Jupyter Notebooks without installing a lot of stuff, is I would recommend is using Azure Data Studio. Azure Data Studio, you can download it off on GitHub, or you can download it off. But this one, Azure Data Studio, allows you to be able to connect and create notebooks, or be able to also connect to your data from there. So it looks something like this. So you can say file, there's new query, kind of like SQL, SQL Studio, or so you have these new notebook right here where you can create it. And of course, you can create a SQL kernel, but one thing that's new is you can change, if you can have these .NET, F# and PowerShell that you can select as part of your kernel, as your kernel. And then you can click code and say console.writeLine, all right? Hello world. And then you can click run, and it would execute that code for you. You see how the code and then the result all in one area. And then if you want to add another one, you can, and specific instructions after that. Notice how, as a .NET developer or C# developer, where's the main function, right? I thought that was weird, that when I first started to learn this, is like, where's that, the main, and where does it start? The notebook itself, it's kind of like a command line interface, kind of like the .NET's not CLI, but be able to just write your program or write the code that you want to run and then execute it one at a time. Kind of like the. So let me go back to the presentation. If you have any questions, just place them on the chat. Feel free to answer them. But yeah, so that's a good explanation, a little bit of explanation how you can use Jupyter Notebooks, .NET Interactive in C#, F#, and PowerShell. So I would recommend if you just want to start and play with this, I would recommend the Azure Data Studio. This would be great if you have PowerShell commands that you're writing down, and then you want a place to where you can add explanation to it to the next person who's going to use it, right? So it's in a way, it's you write the code, there's the result, it saves the result on the that Python notebook, and then be able to retrieve it again and show. So for example, 6 months from now, and you want to rerun that same PowerShell command, and the results kind of give you an idea of what happened or what you can what will happen when you rerun this command. So it gives you an idea what will it do and what are the expected results are. And also you can add documentation, so it has the capability of creating a markdown together with their code. So it's a good way of documenting the steps involved. So also you can use it for C# programs, F#, and that's what I'm going to focus more today. You can also do this in Visual Studio Code. There is an extension for Visual Studio Code that you can install Jupyter Notebooks and be able to run inside Visual Studio Code. There is an extension called DIB. I haven't really delved too much on these, but you can use on Visual Studio Code and open a Jupyter Notebook there. So what you need to search for if you're going to use this is this .NET Interactive Notebook extension in your Visual Studio Code in order to install that capability. Okay. So how it runs in the back end in terms of architecture whenever we talk about kernels, right? So whenever they talk about C# kernel or the Python kernel, it goes into this execution or the language services. So .NET Interactive allows me to be able to have C#, F#, and PowerShell, and also capability of other things that you can expand it, not just limited to these. So what's happening is if I am, like what I showed you, Azure Data Studio, it has this connection to the messaging platform to where the command would send through standard IO or 0MQ, and then there's that instance of your program running in the background that whatever result it would pipe it back up, so it becomes an interactive session, or kind of like it's kind of like a CLI type of command, right? So that this way your kernel is not just limited to running it in one application, but it expands it to notebooks, Data Studio, Jupyter Lab. You can actually create a Microsoft Teams bot that you can go back and forth and be able to run the program in the back end. There's also, that Spark.net also integrates with .NET Interactive to allows you to be able to, and it sounds like the capabilities are growing too. So it's well worth, if you're gonna learn more about .NET it's we're learning more about the .NET Interactive. The easiest way I can tell you, if you want to experiment on this, is to go to the .NET Interactive website, or on GitHub. It's open source on GitHub, and there is a link right in the middle where it says try sample.NET notebook using online or using Binder. So what it'll do is if you click on that, and this launch Binder button right here, what it will do is it would create an instance of, a container that has Jupyter Notebook installed. It has .NET, uh, .NET 5 installed, and then you can start experimenting on these and trying out, if you want to try out C# inside, inside these, um, then you can kind of see how it runs. So that's the easiest way I can find if you're interested in just learning more about this technology, how you would use it as for data exploration. So what I'm going to focus after this is, how do we run Jupyter Notebooks inside Raspberry Pi with .NET 5 in it. So if you haven't heard about Raspberry Pi, it's a device where it's a based from an ARM processor. It's a way for us to be able to, there's Linux installed in it, and the operating system is based from Debian. It's called Raspbian, and it has a way also to be able to connect. Uh, you know, there's this general purpose input output header. You can have, they call it hats, to be able to add sensor data or sensor to my application or to my Raspberry Pi. So it costs about $35, and it's the latest one is Raspberry Pi 4. It has Wi-Fi, it has Bluetooth, and all these. It is a computer by itself, right? All you need to have is micro SD to be able to run your application inside there. There's also a Sense hat that you can place on top of the Raspberry Pi to add sensor data to it. And for me, it's the easiest way to demo to someone the capabilities of, if you want to read some data, you want temperature data, or if you want to display something on these pixels right here, or, you can control it. And of course, there's libraries in .NET that you can control those Sense hat and .NET Core IoT libraries. You should be able to control or to be able to send commands to to your Sense hat from 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 a .NET code or C#. So let me go back there. So in order to install on a Raspberry Pi, a newly installed machine, after you install the operating system, there are only like maybe 3 or 4 commands to get Jupyter Lab running on these. One is, download this setup machine, and this one would, this setup Raspbian would install .NET 5. It would install, you know, it would install everything that you need in order to run uh, .NET on that device. And of course, this one would install Jupyter Notebooks and would link .NET Interactive to your Jupyter Notebooks. And then after that, you can run Jupyter Lab. Jupyter Lab, and I'm going to show you this, is the, it looks like this. Jupyter Notebook is one instance of this, so it's one notebook, right? And then if you want to be able to manage files and switch back and forth, you use Jupyter Lab in order to manage these files. So we're going to go through this one by one. So like I said, if you want to create a notebook inside Jupyter Lab, you just say File, New Notebook, and it would ask you, okay, what kernel do you want to use? Like in this case, I want to use C#, so I can do C# and select that as a kernel, and then I can write C# code in my application. So in this one, I will, and also you can create a new cell. You just specify and click that plus button, and then you can identify, okay, what type is it? Is it code, markdown, or raw? Markdown is, markdown code like this. And then if you want to execute it, click play, and it would format it accordingly. So if you want a copy of my presentation, or this is going to be on my GitHub, and I will send you the link on the chat. Okay, let's start this application. So that one would display it. So this LS Magic, I'm going to make my screen bigger, allows me to be able to run, click that one, a list of all the commands that I can execute in this kernel. So this you'll have application for the C# kernel, be able to share that and all the rest. Then let's go to the next one, and notice that every time I would run, see, there's that F# kernel, and then there's that PowerShell kernel, and there's also a JavaScript kernel, their HTML kernel, and value kernel, all these different ones. So if you want to share from C#, you write your C# code, and you want to run an F# code, you can identify, you can specify, okay, because by default it is, only accepting C# code, and I want to say, okay, I want to run an F#, and this is the F# code. I want to do a console.writeLine and assign values. So just to demo to you that, hey, it can also run F#, right? And if I want to get the variables from my F# kernel to my C# program, I would use share from F# the variable that I want to pick up, right? So from my C# kernel, now I will have the value of X. So if I want to read the value from that F# kernel to my C# kernel, I won't be able to do that here because I'm running in the C#. So I just wanted to kind of give you an idea that there's, two instances of the program running here. There's that F# part and the C# part where you can create and share information. So now if I want, since I have that variable, I can say X plus 2, and if I want to execute or run, I would click the play button, or I use Shift Enter. And notice that it increments every time you run an application or a line, a command line, right, at the end of the day. So now it gives you the result of 12. And if you want to know what our shared applications are, or what are the shared, not shared applications, but more what are shared variables out there, you can use this whos, WO, and then now I know that the variable that's shared is X between those two. And if I want to run a PowerShell commands, I can do this too. So now this one would execute the list of commands. Of course, there's a bunch of commands that you can run, but I want to stop for a minute and want to tell you what just happened. .NET is running. I'm running on a Raspberry Pi, which is a different processor than we're used to, right? It runs on Linux. It runs on an ARM processor, meaning it's not an Intel or it's not an AMD type of processor, or x86 or x64. This running on ARM. And also we can run PowerShell inside Linux now. And I was surprised when I was looking at this, and I was like, wow, yeah, PowerShell has grown into not just limited to Windows, but also into the other parts of Linux too. So I thought that was cool. So for this one, this is how you would NuGet package. You can import NuGet packages to your C# application. So in this case, I want to import the system.device.gpio. This is part of .NET IoT. And this IoT.device bindings gives me a list of all the different not hardware libraries that you can connect to. So there's if you go to that GitHub repo for IoT, .NET IoT, you'll have, there's part there where you can list all the different, hardware bindings you can connect to. One of them is SenseHat, and that's what I'm going to demo today. So in order to run this, and what it's doing right now is it's downloading the packages from, of course, the internet to, NuGet packages, and downloads it to that kernel instance. If you want to list all the kernels that is running at the moment, you go to here, and like in this case, there's about 3 kernels that are running on this Raspberry Pi. So it kind of gives you that list of all that kernels. So one of them is this file that I'm working on. Okay, so now that one's done. If I want to display an HTML tag, so there's the command called span, and you specify, kind of like a, HTML tags, but it's like an minimized representation of it. I can just say display pocket view. See if that one would display, and see that one. It gives me a link to the repo and an href and a link, and then I can click on that and it would just verify that it runs. So notice that I'm running it in the browser, right? But the application is in my Raspberry Pi. I'm on a different machine. This one is I added this warning because it's giving me this error message or warning message, not an error. So I just disabled that. But you can also do HTML tags like these, right? You can specify them, and then I would want to display it. See that one, sensor data. So that's, but notice how it's interactive it is. You write code, run it, and I can rerun it again to say sensor data now, and then I execute it. I don't have to go through and recompile and then run my application if there's a bug or if there's an error, and then back and forth and going from the start of the application. This one is more of interactive type, and that's what I like about it, especially if you're doing exploration, data exploration, or just testing out. So on this one, what we wanted to do is to say, I want to get the temperature from my Raspberry Pi, from my SenseHat, and be able to display it. And every half a second, pick it up, get another temperature reading, and then add it to my list of tuples, right? I have a tuple index and value, and as it goes, it runs that for each. Okay, let's see how that one goes. It didn't execute because it is I need to call that. In this case, I would say read temperature. I want to do it 5 times. Okay, see how that one goes. So notice that I specified, okay, display the output here. So I'm modifying and updating that HTML code to display that values here. Okay. This next one, we'll do the XPlot. XPlot allows me to be able to create graphs and visualize the data that I picked up from my list. So I want to get my values from my list of tuple, and I just want to visualize this part right here. So I can, since I have the XPlot, I have a way to say graph.scatter. I specify what is going to be on my X coordinate and what is going to be on my Y coordinate. So in this case, I want to get the index and then these values and create a chart and pass in, because you can have multiple charts and plot multiple charts at the same time. And if I want to display it, display chart. How it goes. Of course, I got to run. I can't run this one because it's not yet defined. It'll give me an error. So I kind of obvious I didn't run this. So I need to run that part and then display it. And right then and there, I have a chart. When you think about how we would do this in a .NET console or a Windows application, you had to go through all the application type of programming, right? You have to create, and visualize and create a window, and I didn't have to think about that. I can explore metadata as it is right in front as I need it. Of course, this one has different ways how you can do it too. You can filter the data. You can, of course, capture, pan. It has all these capabilities already. It's based from Plotly, if you're familiar with that. Okay, so it gives me the values and of course, index. I have those indexes. Cool. All right. If you haven't used asynchronous stream, here's a good example of what you can use it for. So what I'm doing here is I want to connect to my Sense hat, right? And I want to read the temperature sensor, temperature reading, but I want it to where it is every second. So wait for 1 second and then spit out that temperature, and then wait 1 second again and spit out that temperature. So this async stream allows me to do to read the data as I receive it and be able to accomplish that. So read the data and spit it out, and you have that yield return. So as you receive it, it's asynchronous. Then you can add it to your list. I'm going to add another NuGet package called Microsoft.data.analysis. And what I want to do here allows me to create these data frames. So there's this primitive data frame column that I can specify. In this case, I want date times, and then I want Fahrenheit added to my. And then now, since I am using asynchronous stream, I can just say, as I read the data asynchronously for each, I'm going to do it 15 times, add it or append it to the date time stamp to this column, date times column, and append the result of my, of this call to the Fahrenheit column. So I'm going to start doing that. As I receive every second, it adds it to my data frame columns. So now what I want to do here, after it runs 15 times, I want to create this data frame, and this data frame will have two columns, right? Date times and Fahrenheit. Of course, I always misspell that one, so I have to make sure I spell it right. And so it created that instance, and now I can say df. Notice how they're all garbled together. It's kind of harder to read, but both are kind of mapped, the date times and Fahrenheit as two columns. And this one allows me to be able to show the first 5 items on my data frame and display it properly in HTML. So remember, the rows that add and cells and, So now if I run, and what it does is it registers that, to the data frame, so to display it properly. So it's just a formatter to be able to display it accordingly. So now if I run df, notice that it's mapped. So this timestamp and then the Fahrenheit timestamp, Fahrenheit, all that. That's so to display it properly. So if I want to, so now I have a data frame, I can just say, okay, give me the first 2 rows of that data set. Or if I want to say, count the number of rows, I guess this df.rows.count, I believe, do that. It'll give me the total that I have 15. Even though I displayed the first 5 items here, there's 15 in that data frame. If I want to get, like in this case, I want to create a new column called Celsius, and I want to clone my data frame. That means I want another instance of it. I don't want the previous one. I just want a new instance, and I create, and based from that instance, I create another column. So now I have 3 columns on my data frame. I have this date times, Fahrenheit, and Celsius. See how they're not initialized, but they're mapped according to that data. And so if I want to learn more about my data frame, I can just say, .info. Data frame.info would give me, how many values do we have on that data times column, the Fahrenheit column, and the Celsius column. And if I want to initialize this Celsius column and initialize it to 0, I can just say Celsius.fill nulls, and it would initialize them all to 0. And now it's, all of them, the whole data frame is initialized. And if I just want to get the first row, I can just say rows 0, and that's my first row. These are the values, and these are the type. Cool. So on this next trick, what we want to do is I want to convert my Fahrenheit column and fill it with the Celsius column. This one reminds me of Excel. Remember Excel, where you specify, the formulas in Excel. I just want to say Fahrenheit minus 32 times 5/9. So it becomes a formula, and it fills in those values. So this Fahrenheit value got converted and assigned for each inside my data frame. And if I want to calculate the mean, I can just say Celsius column, give me the, calculate the mean and display it here, and then I'll have that total. See how it's kind of different in terms of exploration, how you would explore the data, and how you would, you would convert the data display. So using data frame, I think it's pretty good. And if I want to graph it again, I can just say chart.plot. I specified those 2 data frames, and it would display it properly for me. So these are the my data in Celsius. Cool. All right, how are we on time? We're running out of time, getting close. Okay, so now in this case, I want to get my data, right? Read the temperature data. I want to add it, to my list. I just want the list. And in this case, I want to incorporate a JavaScript program inside my to be able to display, a chart in a way. But this is how you would do it inside JavaScript. Anyway, we don't have to analyze this, but this one allows me to include a D3 library, D3.js, into my application. And then that D3.js, I can, create, it's more of manipulating an SVG SVG in my screen, or in the browser, and then be able to display it. So anyway, the magic here is that inside JavaScript in the browser, I can actually get the interactive.c# variable and variable name. So the data from my C# application, I can incorporate it to my JavaScript application here and be able to display it. So that's what I wanted to show. Okay, let me try to see if I can run this. So what it's doing right now is, let's see if it's going to show it properly. Okay, I think I missed something. Okay, I need to run this part too, and then this thing. And then if I want to display that chart, right, I can create an SVG tag. What I'm doing here is now I'm not in the C# land. I'm creating an HTML with that JavaScript, calling that JavaScript and plotting it accordingly. So I have that plot here inside that window. So what I want to do is to be able to read that data as I receive that data, update this chart. Let's see if it's going to run. So I'm going to run it maybe 10 times here. So run that read temperature data, since it knows that the variable that it wants to read, I pass in as temp data, which is what I have here on top. And let's see how it runs. So now it's reading 92 point something. Of course, it's not going to be in my chart, right? Because that's beyond my chart, most likely up on top. So I'm going to change this real quick just to show you what I'm talking about here. I'm going to say 92 to 94. Rerun it again, display it 92 to 94, and rerun that application. Notice how as I receive my temperature data, I'm plotting it into this screen. So it's kind of like a live chart in a way. Now I can read it another 10 times and it would continue on, and it would only read the last 10 items. I don't really care about the rest of them. So it's just a way for me to be able to plot as I receive that data. And if I want to count how many times I reran it, see, temp data only has the last 10 items or 11 items. So if I run it again 15, 16 times, even though it's pulling the data, I'm ignoring the last item and deleting them. Where I have that code, if you're interested, if you go back up, is on here. If the count is greater than 10, just remove it, throw it away. And so that's what's happening right there. Okay. So now that we ran that, so what I want to do here now is I want to use this sense hat matrix. So remember, all these application right now, it's running on this small Raspberry Pi here. I just want to, and see if I can demo this correctly. And just to show you that I can control the Raspberry Pi from my browser from here. Scroll down a little bit. So I can say if the temperature is at the certain level, I can trigger this LED matrix and turn it into color red at a certain period of time. So let me try to run that. And let's see. So let's see the reading. Let's do it maybe 10 times. As I read it, 92.3. Of course, we may not hit our max temperature, but let's say I would say 92.20. Let's see if we're going to reach 92.20, 93, 92, 92.20. Let's read it again. Come on, 92.20. Let me reach that one so I can show it properly. Okay, it looks like it's not, so I'll just trick it to like 92.14. All right, there you go. Of course, it's going to reach that one. And it did turn to red because it did reach it at some point, and now it's over that. And if I want to turn that off, I can just say clear LED matrix. Of course, you can do this on a console app if you want to, but I think it's fun to just do that interactive. I can just say black. and say, okay, I want to turn it into blue, and I can change that color and play with it. But you see the interactive side of things. It's a different way of programming, C# the way I was that I learned it back in 2005. All right, let's go back to the presentation. If you are interested in the presentation materials and get the code, I will update it. There are some updates that I need to do on that GitHub on that code, so I'm going to post it later on. And I thought, if you think it's cool, what just happened today, I just want to summarize it. We ran .NET in Linux in an ARM processor in a Raspberry Pi. We were able to control and read sensor data and display sensor data using .NET Interactive, be able to create charts, be able to all in our browser, right? Running inside the browser. So I think that is cool. So if you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacee. I am a Microsoft MVP. If you're interested in learning more about my projects, go to dagdag.net. You can follow me on Twitter. LinkedIn is the best way to contact me. And I appreciate your time. Appreciate you geeking out with me about .NET Interactive, Raspberry Pis, Internet of Things, and have a good day. Any questions so far? Isn't that cool? I think it's it's very interesting in terms of how we can. It's a different way for us to be able to interact with .NET. So cool. I think we have a few minutes. If you have any questions, or if you're ready to go lunch, or you haven't had lunch, this would be a good time. Cool. All right. And if you're a .NET developer and if you want to play with, Raspberry Pi, I thought this is a good way to kind of learn and interact with the Raspberry Pi. It's interactive, right? And learn different how you would do C# and be able to tinker with devices. All right. David Horvath says, it's interesting use of Raspberry Pi. Thank you. All right. I'm going to hang out in a few minutes. If you have any other questions, there's also one part of my presentation, since we have a few minutes, and I want to kind of show you a little bit here, is that I have these also using anomaly detection. If you're not familiar with anomaly detection or anomaly detector, I have a presentation tomorrow talking more about anomaly detector. But what this one does is you send your data, right? We read sensor data to the cloud, and then we read sensor data here and send it up to the cloud to use this anomaly detector, and it would detect if there's anomaly based from that data, and then it would do the alert. So I'm going to demo that tomorrow. Feel free to come back for my presentation tomorrow. All right. Have a good day, everyone. I'll talk to you guys later. Bye-bye.